Okay, the next topic that I like to discuss is piecewise defined function. Piecewise defined function. For some reason, um, every time that I teach this section, a lot of students typically get confused, right? So let's see if you can follow this. The piecewise defined function, as the name suggests, they are defining a single function but in a several different pieces. So several different pieces combined to be a single function. Combined to be a single function. So let me give you an example. And let's say we have f of x, a function, but it actually has three different pieces. So first piece is x negative x plus 1. The second piece is just 2. Let's say the last piece is x not cubed square. So when do we have this piece? X becomes negative 1, negative fx becomes negative x plus 1. Well, when x is between negative 1 and 1, you know that this double line means equal to, and this is x is less than 1, right? Not equal to is not included here, but this double line means it's equal to. So when do we get 2? When x equal 1. And when do we get x squared? When x is actually bigger than 1. So we have these three different pieces all combined to be a single function. Function defined in this manner is what we call piecewise defined function. So let's try to graph this, right? Let's try to graph this. So first of all, let me have this graph, and according to this function, we have these three different fields when x is between negative 1 and 1, when x is actually 1, and when x is bigger than 1. So where is this x being between negative 1 and 1? Where is that um, reason? Well, that area should be, let's say if this is negative 1, and let's say this is 1, and that area should be between negative 1 and 1, this area right here. So let's say that's f of x, and this is x. So when x being between negative 1 and 1, what's our f of x? Well, our f of x is this, which is what? Which is something like this basically. Between these two, we have to graph y equal negative x plus 1. I'm getting this right here. So we're going to graph this line, but we are only going to do so where x is between negative 1 and 1. And according to this definition, above negative 1, we have this equal sign, so we are going to have a solid closed dot. But above, when x equal 1, it's not included, so we are going to have this open circle, right? So how do we graph this? Well, I hope you know how to graph a simple linear equation. If you do not know how, please go back to the previous chapter and make sure that you know how to graph this, right? I mean, there are several different ways. You can find the x and y intercept, or you can use the y-intercept in the slope. There's more than one way to figure it out. Anyway, if you graph this, this will be actually a line that should look like this. But we are only going to take this line between -1 and 1, between -1 and 1. And above -1, we are going to use the solid dot because we have equal sign. Above 1, because we don't have equal sign, we are going to have open circle. And this is the case for this part of the function, right? So right above -1, we're going to have nice big closed, and we're going to have a line passing through all the way down here. And here we are going to have open circle like this. All right, what's next? When x is actually equal to 1, the fx is defined to be constant function 2. But it's just one point though. Right above x equal 1, just one single point, y value is going to be 2. So where is it? When x equal 1, y value is going to be, let's say that's 2, right there. Nice closed, right? Okay, so we dealt with the second line, right? We've done the first and the second line. What's the last line? When x is greater than 1, our function is defined as x squared. This is the square function, right? But this will only work when x is greater than one area. X is greater than one area is this area. If you originally graph the square function, if you remember the square function, this is square function, it should look like this U-shaped curve. But we are only going to use this curve, this dotted graph, between x being greater than 1. So right at point 1, we're going to have, we're going to have a point, but open circle. Then along with the line, we have our graph. That looks like this. So between -1 and 1, we have this nice solid line, right? Nice solid line. And right above 1, we have just one single point. When x being greater than 1, we have this line right there. And that's going to be the graph of this piecewise defined function. Okay? All right.